Good morning, and Hamlet Batista here from Ranksys. Thank you very much for the opportunity. Jason, can you confirm that you guys can hear me okay?
Yes, we can hear you. You're perfect. And you look wonderful.
Oh, thank you. Appreciate that. So I'm really excited about this topic that I picked for this talk. So I hope you guys also join me on this geeky ride to the worlds of machine learning, intent classification, Excel, and a lot of really cool stuff we're going to be looking at. So let's start with breaking one of the strongest frameworks in marketing that has been for years, which is the buyer's journey, right? So everybody understands the buyer's journey, the transition of a potential buyer through the different stages has been for many years one of the strongest and important marketing frameworks. And I want to invite you to check this research from Google. If you follow the link at the bottom here, found that this is no longer the case. That now with all the devices, all the ways that people interact with brands and websites, they challenge this notion that people follow linearly a path to purchase. And every user can follow a completely different path, and some of them even many different touch points. And in this example, Ava, she made 500 different touch points. And if you look at the example searches, all-inclusive scored tours of Ireland, Irish classes tour, branding tours. And the thing is that a lot of these happen even after she completed the purchase. A lot of times we understand that after you finish the purchase, you're done, but that's not the case. So this is really interesting. I mean, you think about it, it's very complicated because it's like, how can you track so many personalized? You want to think about it is that all these intent journeys are personalized. So how can you actually keep up? How can you actually action on this information that users can be behaving in completely different ways? And the answer that Google provides here is, which is my favorite topic, is automate everything, right? Is automation is the answer here. And we're going to automate with what? With machine learning, obviously. So this is a quote from the article from Google. Machine learning can help you understand and predict intent in ways that simply aren't possible manually, right? And that leads me to get into the exciting part of my presentation, which is I'm going to walk you through building an intent classification model that not only looks at intent as, informational, transactional, or looking at just classifying the query, but looking at also not just the intention, but also even the context of the query. And this one is my favorite example here. And we're going to be able to do this in Google Sheets. Show me all the flights from Atlanta to San Francisco, which leaves the day after tomorrow, after 5:00 p.m. And with a simple Google Sheet function, fetching prediction, I am able to determine that it's about a flight, but more importantly, I'm able to break down this query into the components of the search, which is from what is a query that is asking from one city location to another, or it's also including the departure time, and it's including all this relevant information. Parse queries in a standard format like this, you can find gaps in your content strategy that can be really granular, right? And this is in Google Sheets. So it's like, how do you be able to do this in Google Sheets, right? What kind of formula will be able to pull up something like this? So this is going to get really interesting. So this is going to be our agenda. This is how we're going to be doing this. So we're going to build a sophisticated deep learning model that is going to do what I just explained. And this is the same type of model that powers Google Assistant, Siri, and Alexa when you're asking questions. So now you're thinking that search engines are becoming more answering engines. And I'm really looking forward to that talk from Kevin Indig about it. So make sure you stay around to check it out. We're going to take this model and access it from the function that I just showed you. And I'm going to explain a little bit of the concepts that make this possible for you to learn more about it. So let's get started, right? So let's talk about our toolkit. If you've seen my writing and my talks, there's always code in my talks and in my writing, right? So we're going to be geeking out. But this is probably the talks that I was going to have the less Python or JavaScript code that you'll have from all of them, because this is so easy that even if you only know basics, you should be able to follow me with this. So the toolkit is Google Collaboratory. You can follow it on this link. And I'm actually going to show you how to get started. They're going to use another tool. This is the core of that enables the intelligence in our model, which is called Ludwig from Uber. So this is another tool we're going to use for this. It allows you to build models without having to write Python code. And we will use this data set. This is an open data set from the travel industry. I want to fly from Boston at 8:30 a.m. So this is the data set that we're going to use to train and our model on the tasks that we're given. And if you don't have the link, I'll be tweeting the slide deck at the end, so you have it. You can follow the links. Another, which is probably a tool that you've never heard of, is called Ngroup. So this tool will allow us to expose the model that we're going to build in Collaboratory, make it publicly accessible. And then finally, we're going to use Google Sheets. We're going to use AppScript to be able to code the function that is going to access that model and make it available in Google Sheets. Okay, so now let's talk about the first step, which is setting up the notebook, right? And I'm going to pause the presentation to show you how easy this is, right? So open this link, right? And we're going to go here. Okay. You're going to see this open Git repository, and just click on Open Google Colabs. This is going to give you an open notebook where you're going to be able to just go in and type the comments that I'm going to give you, right? So I'm going to show you a few things first. I'm not going to do all the coding here because of the time constraints, but I just want to make sure that I show you how to get this set up, right? First thing you're going to do is make sure that you change the runtime to GPU, right? Save it, and then you're going to connect. And this is, if you have Google Drive, you should have this. And this will allow you to type the comments that I'm going to give you. And let's do one example comment so you can see how this works, right? So these three comments, which is setting up TensorFlow, and then we'll put it here. Okay. If I paste it, pasting is not seem to be working. This is live, right? So let me do it manually. Okay, so use the autocomplete. See if I did it right. Then you type this. Okay, so I run it like that, but you can make a copy of it. I recommend you making a copy to your site. So I did that. Let me do the second comment, and you're going to be just copy and pasting comments that I'm providing you here. But I'm showing you how easy it is. I think I have to do this because the default now is version 2. It was 1.15.2, sorry. All right, so that's it. So You type that, and then you make sure that you have the right version. Okay, so all these comments in TF version. Right? TF version, sorry. Okay, so that's what you're gonna do, is just type in the comments that I'm gonna be showing you here, and we should be good to go. The next one is Ludwig, as I mentioned. Pip install the same thing, type the comment here, and you'll be good. Then after we install Ludwig, download the data set, log into Kaggle. You have the link here. I move this, and download it to your computer, and then you're gonna upload it to Google Drive. Google Drive, after you upload it to a directory in Google Drive, what you're gonna do is, in the Colab, you're gonna connect Google Drive to the notebook, right? And all those steps take a little bit more time than we have, so I'll have to just show you here. And you're gonna mount the drive. In this case, you see that? This is where the directory, where I place it. It might be completely different in your case. So make sure that you might need to change that. Okay, and then the last one that we're gonna install is Ngroup, as I mentioned. Just you download it here, install it, and I'm gonna show you how to use that. Okay, so we did this setup steps for the configuration for the training data. Okay, so now in Ludwig, we're gonna use one of the examples in Ludwig. And you see that we're gonna use a natural language understanding example. And you see that it's very simple. You just run a comment when we provide the source data that we downloaded, and we're gonna create a model definition file. And once we have the model definition file in our data, the system is gonna try to learn from this data set so that it's able to, just using the first column, predict the other two columns, the intent and the slots. This is called the slots. Right? And we're just gonna take this example, and we're gonna make some small modifications. And I have another link here. I created a gist for you that you can click and open. This gist has the model definition that I made some small modifications. In this case, I changed the name to tokens, which is the name of the first column on the ATIS data set that I created. And yeah, that's it. So now we can build a predictive model. So it's very simple. So it's no Python coding, nothing. Just type this command with the data set, with the model definition file that we created, right, in the notebook. Note that when you copy this in the note, you have to copy this in the notebook, and it will actually create the file within the notebook with this code that I have here. So when you run this, it will run for a little bit of time, and that's what I asked you to set it up as a GPU so that it will run actually faster. It will take about 20-something steps, the accuracy statistics. So from the intent classification, the accuracy is really high. We split the data set in three groups: training data, which is the bulk of the data to be able to, that the model is going to learn from. The validation set is used for the model in every step to adjust the hyperparameters dynamically and learn. So during the training, the training and the validation are used. And after the model, in every step that the model is built, then we use data that the model hasn't seen to verify that it's doing the work correctly. And but the test is the real proof that how good the model is. And you see that we get about 65%, which is really good considering that we didn't have to do any deep learning expertise to do this. We just copying examples and everything. A deep learning researcher might be able to get this a lot higher by tweaking things, right? So now how do we predict? So I have some Python code snippets here. I can't avoid including Python code, obviously. So I'll only a few lines of code here to use the test data set to verify, whether the model works on test data, right? So just copy and paste this, and this is what it looks like. So you see that there's BOS, it means beginning of sentence and end of sentence. So this is kind of a convention on this data set. And then these are the predictions for the intent and the slots that the system was able to extract, right? And you can adapt this, just need to have the data set for any industry, food industry, travel, hospitality, e-commerce. Once you have the label data set, you can train the model to be able to predict things really good, right? So the next thing is now that we build this model, how do we expose it, start exposing this model so that we will be able to use it from Google Sheets, right? So the first step is that we're going to use serve, right? I have that typo here, but it's serve, to basically serve the model. And this is what I love about this tool. It's so simple. You don't have to do any coding. So we want to run it with this command, right? This is what it looks like. When you run it, this is going to run in the background with this instruction, bash background. And then you can run this command tail debug.log a couple of times as you see the progress until it says, okay, it is completely up. Now, the challenge with this is that this is only visible within the notebook. This IP address is only accessible privately within the notebook. But we're going to talk about how we address that, right? Now, how do we test the model from an API request perspective? We're going to use another tool called curl, and we're going to run comments against this service that we just started. And in this case, we're passing the test search, beginning of sentence, give me a flight from Baltimore to Newark, end of sentence, right? And that's the test. So that should return the response in JSON, right? Now we need to expose the service. We need to create a public URL to expose the service. And that is with ngroup. That's what we install at the beginning. Ngroup is an interesting service, which is a proxies connections. So you can have a private connection within the notebook or in your computer, and you can create it and expose that connection by mapping the TCP port that you have locally with one that is going to be exposed in the ngroup service. So this is a very obscure tool that is more it's very well known by people, network admins and people in sysadmins, not necessarily web developers or SEOs, but it's always interesting stuff to learn new things. So after we have the ngroup, we need to learn what is the URL that is going to be exposed. And as I said, a lot of this stuff might be Chinese, but I'm going to be tweeting the deck. You just have to copy and paste the codes into the notebooks and you're going to get the response. After you run it, it's going to return a temporary URL. In this case, I only needed to replace, if you look at this, the 00.8000, just have to replace it with this weird number with ngroup.io, and that's it. And now I have a public URL I'm being able to access the content that I have, the service that I created inside the Collab notebook, right? So the next Now let's summarize what I've done so far, right? So we build a travel-specific intent prediction model, and we're able to access it from a temporary URL. The next phase, is just to access it directly from Google Sheets, and we're going to use AppScript for that. So how do we do that? So we're going to create a custom function in your sheet. You're going to go to the script editor, right? In the script editor, you can copy and paste. I have another link here for a gist where you can copy and paste this fetch prediction function. Sorry. But before you run it, you have to replace the URL. You see that I have the end group URL. Yours is going to be different because this is temporary. Actually, this one is no longer valid because I ran it yesterday. So this is, you have to replace that function, and then you copy and paste it here, right? Copy and paste it here, and you want to test it, make sure that it works. So you go to click on the play button here, and then you're going to be able to go to the logs, and this should be the output that you should see. You should see the input encoded. So I had to encode it to turn it into a URL, and these are the intent predictions in a JSON, output. So you should be able to see that. You see that it was run from the editor. So now you can call our function. That's it. Fetch prediction, save it, and we can provide the keyword that we want to predict, and that's it. And we have a service. So obviously this is a temporary. This is for testing in the notebook. It makes sense. But if you want to have it in a permanent place, you have to set up a server and deploy the whole steps in the server and have a URL exposed. So it's going to be a little bit more work, but for testing, this is good. Any changes that you're making in Google Sheets are going to be logged here, so you can see the custom function calls. It should work correctly, right? And all the things you can do in the notebook is you can look at the debug log and see the calls. As you're making the calls, you will see that they're coming into the notebook. So this is really, really cool stuff that you can do. Where's BERT here, right? So I originally was trying to do this with BERT, and I'm sharing the model definition file that I use for that. It's a little bit more complicated. It has a little bit more steps. But the reason why I decided not to use it is because the performance was worse than the simpler model, right? So that's the bad news on that. But hopefully I'll share in somebody that is an expert on this stuff, figures out maybe some better hyperparameters to get this to work better. Okay, and yeah, so these are some resources for you to learn more about this. Check my articles. I have a column in Search Engine Journal, and 3 articles that I use to pull this together. Potential classification using Google Sheets. You'll be able to find a lot of the codes here. The intent classification article and part 2, right? If you're starting on Python, I highly recommend this complete guide in 5 chapters. And have the link, and Whiteboard Friday from the brilliant Brittany Mueller as well to check it out. And thank you. That's what I have for you.
Absolutely brilliant.